Have you ever wondered how architects design complex structures, meticulously planning every curve and angle to create stunning buildings that defy gravity? Or how animators bring characters to life, making them move with such fluidity and realism that they seem almost real? It's all about understanding how shapes move and change, which is exactly what we explore in transformational geometry. This fascinating field of mathematics allows us to manipulate shapes in ways that can be both simple and incredibly complex. Transformational geometry is like a secret code that unlocks the mysteries of shapes. By learning this code, we can predict and create patterns that are both beautiful and functional. It's about moving and resizing figures without changing their basic properties. This means we can stretch, shrink, and rotate shapes while keeping their fundamental characteristics intact. We'll dive into 4 key transformations: translation, reflection, rotation, and dilation. Each of these transformations offers a unique way to manipulate shapes and understand their properties. These transformations are more than just fancy math terms, they're happening all around us. From the way leaves grow on a tree to the design of modern architecture, transformational geometry is at play. Think about the symmetry of a butterfly's wings, where each side mirrors the other perfectly, creating a stunning natural pattern. Or the movement of cars on a road, where each vehicle follows a path that can be predicted and analyzed using geometric principles. Even the simple act of resizing images on your phone involves transformational geometry, allowing you to adjust pictures without distorting them. Get ready to see the world through the eyes of a mathematician as we unlock the magic of moving shapes. By understanding these principles, you'll gain a new appreciation for the hidden geometry in everyday life. Imagine pushing a book across a table. That's translation in action. It's a simple yet powerful concept that we encounter in our daily lives, often without even realizing it. In geometry, translation is simply sliding a shape from one position to another without changing its size, shape, or orientation. This means the shape remains exactly the same, just in a different spot. Think of it like this. Every point in the shape takes a little ride in the same direction and for the same distance. It's like a coordinated journey where every part of the shape moves together. We can describe this movement using a translation vector which tells us the direction and distance of the slide. This vector is like a set of instructions for the shape's journey. Translation is like a choreographed dance where every point in the shape follows the same steps. Just like dancers moving in perfect harmony, each point in the shape moves in sync. Whether it's a car moving down a straight road or a cloud drifting across the sky, translation is everywhere. It's a fundamental concept that helps us understand movement and positioning in the world around us. Look in the mirror and what do you see? A reflection. In geometry, a reflection creates a mirror image of a shape over a line called the line of reflection. Imagine folding a piece of paper in half and tracing a shape on one side. When you unfold the paper, you'll see the original shape and its reflection. That fold line is the line of reflection. Reflections preserve the size and shape of the original figure, meaning the reflected image is congruent. From the symmetry of a butterfly to the reflection of mountains in a lake, reflections are all around us. Section 4. Spinning into rotation. Picture a spinning top or the hands on a clock. That's rotation in action. In geometry, rotation is all about turning a shape around a fixed point called the center of rotation. We can describe rotation using 2 things, the center of rotation and the angle of rotation. The angle tells us how far we're turning the shape. Just like a dancer pirouetting on stage, shapes can rotate clockwise or counterclockwise. From the rotation of planets to the turning of a doorknob, rotation is a fundamental movement in our world. Section 5. Dilation. Size matters. In this section we will explore how changing the size of objects can help us understand the world around us. Ever use the zoom feature on your phone's camera? That's dilation. It allows you to focus on details or get a broader view by adjusting the size of the image. In geometry, dilation changes the size of a shape, making it bigger or smaller. This concept is crucial in various fields, from art to engineering. The key to dilation is the scale factor, which tells us how much to enlarge or reduce the shape. Understanding scale factors can help in creating accurate models and designs. A scale factor greater than 1 means we're making the shape bigger, allowing us to see more details or create larger versions of objects. While a scale factor between 0 and 1 means we're shrinking it. This is useful for creating miniatures or fitting large objects into smaller spaces. Dilation is like using a magnifying glass to zoom in or out on an image. It helps us examine details closely or get an overview of the entire picture. From resizing photos to understanding how architects create scale models, dilation plays a vital role in various applications. Dilation is a powerful tool for understanding size and proportion. It helps us make sense of the world by allowing us to manipulate and compare different sizes effectively.